Yeah, hello folks, we're coming to the part 8 video of this miscellaneous exercise, and here we have this question which is giving you a matrix like this, and they are asking us to show that this overall value of this determinant is coming as 1. So we have to see what strategy can help us. In the earlier problem we divided it into 2 parts and got, but that is not going to help here because there are too many additions. So there was only one column with addition with the plus symbol, so we could break it into 2 parts and we could do it. But here it is not like that. There is an addition in this column also, and there are 2 additions in this column, so that idea is not going to work. We have to search for another strategy, but till the time that we get that strategy, let's go for a ground rule of making these 2 zeros. We know that we can do R2 minus something so that it becomes 0. We can do R3 minus something so that that will be 0. So your expansion becomes easier. At least let's start with that. So we will first consider the LHS, and we will use our strategy by which we will do R2 becoming R2 minus 2R1. That's an attempt to make it 0, because 2 minus 2, when we have 2 into 1, then 2 minus 2 will be 0. If we can simultaneously do, let's also try R3 becoming R3 minus 3R1. Let's try whether how it is coming. Now this will be minus 2. This will be 2 times 1 plus P. This will be 2 times 1 plus P plus Q. Let's see what comes. 1 plus P, 1 plus P plus Q. 2 minus 2, 0. Now this is minus 2 minus 2P. So 3 minus 2, it's 1, and 2P is getting cancelled. Now here it is 2 plus 2P plus 2Q. So 4 minus 2, it is 2. 3P minus 2P is P, and 2Q is getting cancelled. Same way here. 3 minus 3 minus 3 times 1 plus P minus 3 times 1 plus P plus Q. So minus 3 minus 3P minus 3 minus 3P minus 3Q. Let's see. First entry 0. Next entry is 6 minus 3, 3P is getting cancelled. Next entry it is 10. 10 minus 3, that's 7. 6P minus 3P, that is 3P. And 3Q minus 3Q, that's 0. So this is your overall thing. Now at this step itself, you can go in for expansion and you can try to see whether you are getting the value, or otherwise we can go in for further solving to make it more simplified. Here we have 3, here we have 1. Let's think on that lines, and we can say that maybe R3 becomes R3 minus 3 R2. So what will happen? Here it is 1 plus P, 1 plus P plus Q. R2 is as it is 0, 1, P plus 2, but this is minus 3, and this is 3 times 2 plus P, which means it's minus 6 minus 3P. So it will be 0, 0 and 1. So that's fair enough. Now we can go in for an expansion. So we know that because there are these 2 zeros, these 2 will not give us any answer, only this will give us an answer. So 1 times this determinant. 1 into 1, 1, the other entry is not there because it is 0. And these entries are not going to be there because even if we expand, there is 0. Even if we expand, there is 0. Finally, the value is 1, and that is our RHS. Hence put. That's our problem number 14. Now problem number 15 also, they have given us a trigonometric thing and they have asked us to show that it's equal to 0. So let's start right away by considering the LHS and expanding the last column. Consider the LHS, and right away we will expand the last column. Sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma, and the expansion here is cos alpha, cos delta, minus sin alpha, sin delta, cos beta, cos delta, minus sin beta, sin delta, cos gamma, cos delta, minus sin gamma, sin delta. Now we have learned earlier that if at all one row or one column has got addition, then you can break it into 2 parts and manage the determinants like that. So our first part is going to be sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos gamma, and the first part of this, that is cos alpha, cos delta, cos beta, cos delta, cos gamma, cos delta. Now actually technically by the property it is plus, but because there is a minus throughout here, we could also write it as minus. That is also allowed. Sin alpha, sin beta, sin gamma, cos alpha, cos beta and cos gamma, sin alpha, sin delta. Then sin beta, sin delta, sin gamma, sin delta. Now we can see in both these determinants, here cos delta is common and here sin delta is common. Let's take it common. In the first determinant we are taking cos delta common. So what are we left with? Sin alpha, sin beta, sin delta, cos alpha, cos beta, cos delta. Last entry, cos alpha, cos beta, cos gamma. This one we are having sin delta common, so we are taking it out. What are we getting here? Sin alpha, sin beta, sin gamma, cos alpha, cos beta, cos delta, and last entry it is sin alpha, sin beta, sin delta, sin gamma. Now we can observe these two determinants and we'll find that in this determinant these two columns are identical and in this determinant these two columns are identical. We have learned that whenever a determinant has either row or column identical, then its value becomes 0. So like that, this will have a 0 value. Cos delta times 0 minus sin delta times 0. Why? Because these determinants are having the either of the columns identical. Like that, the overall value becomes 0. That's how we are able to get the LHS equal to RHS, and that's how we are able to prove the result. Hence, that's about this problem, and that's how we finish this. Some more problem left that we are taking it up in the next video.